We want to evaluate the given double integral over the region defined by R. Notice how we have two closed intervals here. The first closed interval is for x, and the second closed interval is for y, and therefore we have a rectangular region of integration shown here in the xy plane. Notice how this rectangle is defined by x from 0 to 3 and y from -2 to 2. So the next step is to set up the double integrals in the order of integration. So the integrand function is x y squared divided by the quantity x squared plus 1. Let's integrate first with respect to x, then with respect to y. With respect to x, we integrate from 0 to 3, and for y, we integrate from -2 to 2. When we integrate with respect to x, we have to perform u substitution. Notice how we have a factor of x in the numerator, and we have x squared plus 1 in the denominator. So we'll let u equal the denominator of x squared plus 1, which means differential u is equal to 2x dx. Notice how we do have a factor of x dx. Let's go ahead and divide both sides by 2. So now we know that 1/2 differential u is equal to x dx. Now let's rewrite this in terms of u. We know our denominator is going to be just u. And we know we're treating y squared as a constant. And we also have x dx, which is equal to 1/2 du. Let's write this as 1/2 y squared du, and therefore the denominator here would just be 1. Now if we integrate with respect to u, notice how we'd have 1/2 y squared times natural log absolute value of u, which means in terms of x, we'd have 1/2 y squared natural log. Absolute value of u would be absolute value of x squared plus 1, which is always positive, so we can leave off the absolute value and just write natural log of x squared plus 1. And now we'll perform substitution for x using our limits of integration for x. So when x is 3, we'd have 1/2 y squared times natural log 3 squared plus 1, and then minus natural log 0 squared plus 1. But natural log 1 is equal to 0, so this simplifies nicely to the integral from -2 to 2 of 1/2 y squared natural log 10. We could also factor out the 1/2 and natural log 10. Let's go ahead and do that. We'd have 1/2 natural log 10 times the integral from -2 to 2 of y squared. And let's go ahead and finish on the next slide. We'd have 1/2 natural log 10 times the antiderivative of y squared would be y to the third divided by 3. Let's go ahead and factor out the 3 from the denominator, which would give us 1/6 natural log 10 . Now when y is positive 2, we have 2 cubed, minus when y is -2, we have -2 cubed. So this is equal to 1/6 times natural log 10 times, here we're going to have 8 minus -8, which is equal to 16. And 16/6 is equal to 8/3, so the exact value of the double integral over the region of integration is 8/3 natural log 10, which is decimal approximation will be approximately 6.1402. I hope you found this helpful.